So yeah, hello everyone. Thanks for the full room. There's a side right here if anyone wants to. No, but yeah, well, today we're going to talk about containers, and the first thing I'm going to do is I'm going to be a bit meta, not as in the company, like I don't want your information, but in the sense of that I'm going to talk about the talk a little bit, or rather about the topic. So the thing with writing good container files is that it's very, very verbose, which makes it very unappealing, and it makes it easy for people to want to skip and take a shortcut. If you're going to do that, I highly, highly, highly recommend you use Jan Smitka's Docker files. Well, he had a talk last year in EuroPython. Excellent, excellent talk. Highly, highly recommend you watch both the talk and take a look to his Docker files. Very, very high quality, and insofar as possible, I will try to make my talk complementary to his because I just couldn't do what he did better. So if you're going to just take something, take that. But I also want to bring to your attention that this random Docker file that I picked has 101 lines of code, which is absolutely like preposterous for something that's not actually code. And also the fact that many things that you will find in articles, in Medium, stuff like that, is actually very much wrong and dangerously wrong at places. So also, by the way, AI doesn't really help. I've been very nice to it, I think, but it still hasn't given me a totally good Docker file. It's not entirely terrible, but we will figure out in which ways this can be improved. Here's a larger kind of print of said Docker file. By the end of the talk, you'll know how to improve upon this. Not the worst I've seen, but actually we can do much better. So. Insofar as possible, I will try to give you information that I think hasn't been given before, or that is not as easy to find. Part of the reason why is that, as you see here, if you take the first page of the kind of the Docker documentation, and you go to best practices, the number one thing is multi-staging, which is totally fine. You should know about multi-staging, and it's important, but it would be terribly condescending for me to go and tell you the first thing that comes into the docs. I think you don't need anyone to tell you that, and certainly not, you can do that by yourself, right? So I will try to give this talk kind of a different spin. For this, I will try to argue for good practices by kind of playing devil's advocate for a little bit. So I will try to justify skipping on all of these good practices, or I will try to argue for bad practices in a way, or at least try to get through the correct implementation, or just in general the correct way of doing things through a kind of Socratic way of in a conversational Socratic way, let's say. You'll see what I mean in just a second. In this manner, my hope is that instead of giving you kind of just a file that you can plug and use, that you more or less widely understand the principles of what makes something good and what makes something bad, so that if you take and copy something, you at least know what you're standing on, and that if tomorrow the syntax changes, you already know what makes for something that you should do and what you shouldn't do. So, since the talk is in Italy, I thought I would localize the talk and make it a bit more engaging by including some of the most famous Italian characters in recent history. So I have tung 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 sahur. I'm really glad someone actually got this reference. It would have been terrible if no one got it. But so he will play devil's advocate. If you see this guy on screen, it means don't actually follow what he says. I'm just being intentionally sort of misleading. And also, this is kind of, I mean, this is not entirely related to the talk, but someone wrote like a wiki page, and this guy has superpowers or something. It was just very funny to not include. The amount of weed that you have to smoke to come up with this bullshit is just insane. So this was very funny. And of course, the actual good practices guy, you know who it's going to be. The one and only Tralalero Tralala. So every time he appears on screen, you know that this is more or less what we are arguing for. So seeing this, I have first two kind of, I only have sort of two principles to follow. As you saw, the good Docker files are hundreds and hundreds of lines long. I think just if you take away two things from this talk, it will be more than enough for you to understand what makes something good and what you should be striving for. And one of them is applying the principle of least privilege. This is something that's fairly common sense and applies in a wider scope than just Docker containers. But it also should apply to Docker containers. And you might argue against this. You might say, wait, why should I care so much about, I guess, in container security? It's an isolated environment. I don't really care what's inside. If you break into it, well, it's you can think of it as a virtual machine and you're kind of boxed in. So why should you care so much, especially if I have to bother about including all of these directives to make it safer? Well, it turns out that you can actually, you can argue against this. Containers are not really bulletproof, and you shouldn't think of them like that. You can leak a lot of important information. There can be vulnerabilities in the runtime. You can never really count on things being as safe as they would ideally be. So it's just in general a very good practice to try to scope down the permissions that your container will have, even in a container, right? Also, some compliance and security policies might be broken if you don't do this. So you might get fired, and I'll tell your boss and all of that. No, I won't, but OK. So so in order to do this, the way to achieve this is by using the user directive. This makes it so that you do, well, it does more or less what it says. It changes your user. The thing is, many images do already have a preset or predefined user that's not the root one. However, this usually happens in prepackaged applications or such. So if you pull like the Airflow image, you'll have an Airflow user. The Python images that you'll find in Docker, in the Docker Hub, are not really serving any application. They're just for you to use. So they don't set a user separate from root. That's kind of delegated up to you. And this is how you do it, and this is what you should be doing. It's very good practice to create a user for the application and switch back to the root only for things like updating the system packages. This way, well, the environment in which your container is executing only has certain permissions over your application, but not about all the container system. And another suggestion kind of tied to this that I have, or at least tied to the entire rootless versus rootful conversation, even if it's outside of containers and not inside, is to maybe give Podman a try. This is, for those who don't know, it's you can think of it as a more or less a drop-in Docker replacement. And it's reached more or less feature parity. Maybe 5 years ago or so, it was still a bit inconvenient to use. Some features were not as advanced, and you would have things like performance issues and weird quirks and bugs. I think those times we're past them, I think, at this point. Podman is a reliable tool, and the trick, or why it's relevant to this part, is that it's rootless by default. So when you run a container, instead of talking to the systemd or service that's spawned by root, Podman forks off of your user space. So the container that you're running doesn't have permission over the entire file system, or just the entire, let's say, operating system, as hypothetically a Docker container could. So this can be useful for development. I find that it's really useful for knowing when you're abusing unknowingly your root privileges. For example, one common case, or at least it has been common for me, is that you're mounting a volume locally in your machine, And then later, when you try to delete the folder in which that volume is mounted, you find that you cannot, and you have to use root because the folder has been created by Docker, not by your user. That's kind of common, and that's something that's inconvenient, and also that points to you abusing your super user privileges without really knowing that you were doing it. Podman will not allow you to get away with this. It will just not work. So maybe give it a try. It's not, I mean, Docker is fantastic, and Podman just works as well. So pick whichever you like the most, but it's an interesting project that may be worth checking out. Then the other big principle that I have is that the smaller your container, the better. Normally, these types of large statements or generalizations tend to be not entirely correct. For example, not necessarily the shortest code or the less lines of code is always better. So why should the less size be better, right? Well, it turns out that this generalization is, for the most part, a very, very good rule of thumb. You might think that that's not the case. By the way, that's a real video thumbnail right below that. That's like a real YouTube video that I, of course, haven't clicked. So you might think, why do I need to care about size so much if storage is cheap, network transfer speeds are very high, and why do I care about like 100 megabytes here or there? It's like we have terabytes of storage and a lot of gigabytes of network speeds, right? Well, it turns out that you should care about size because it scale, especially at scale, you do notice these differences. The most important point, perhaps, is that the smaller container is by default and by definition safer. The less applications you're bundling in your container, the less surface area you have for attacks. Also, and as I mentioned, you will notice this more at scale, but this is generally true. It is cheaper and faster to have smaller containers, especially if you're deploying something like if you're deploying from a registry, those pool times, if you're deploying a lot of containers, you will start to notice them. The cost is noticeable, especially if you're doing cross availability zone type network pools. And the spin-up time also is relevant in the case of size, even if it's a relatively small change. So you should care about it. So in order to know how to reduce the size, I will briefly go over the base images that we have for the Python kind of Docker hub. To sum it up, the preferred one has usually been the slim variant. So the slim variant is a kind of a trimmed down Debian image. I think it's a very good compromise between size and conveniency. It's not as inconvenient as Alpine, but it's also it's also very much reduced versus the kind of more bloated standard Python image, which if you read actually the Docker documentation and you read the page that they have in Docker Hub, they do recommend the big one. It feels a bit kind of self-indulgent to criticize that. I mean, the people who have written that surely have the reasons, but I think that by all means, like in 90% of cases, you do want the slim variant, and then add whatever you need after. And then we're going to talk about Alpine, and this is where I will slightly go against the grain. Many people who are very good with containers will argue that you shouldn't use Alpine, that it's not worth the trouble. So there are some caveats that you need to take into account. It can be slightly slower. Some wheels might not be available, and it's rare, but it could happen that if you're making heavy use of C, something might not entirely work. However, I've come to find that the support overall has gotten way better. We have way more wheels in Alpine now for different architectures. The image is, well, it is smaller, so there's a small gain to be made there. And if you're not doing, networking issues have been more or less solved. This used to be a thing, especially in Kubernetes environments where people would have problems with Alpine. This is now a thing of the past for the most part. And even though you need to take these things into account, and for highly specialized software, if you're doing something like data science, machine learning, or you need very high performance and very specialized programs, in that case, I would just recommend the Debian one. But for normal web development stuff, and you see a list of dependencies right there that I have in an application in which I'm running Alpine, and you might think that, well, that's pretty stupid, you have nothing. But that's kind of my point. If you are not doing anything special and you don't have any particular need for anything C-specific, I don't think that it's too bad using Alpine. I think you can get away with it, and it just works. So in these cases. So my suggestion is maybe give it a try. It's maybe not as bad as you would have expected it to be. Then I want to talk a little bit about updating the base image. So what I mean by this is using the system's package manager to update the operating system, right? So running apt update before doing anything. Now, should you do it? Because many people don't, including GPT, as you saw. And you can very reasonably argue against it. It, in fact, goes very much against a lot of the things that we have said are good. It will take longer to build the image. It will take longer to download these packages. The image may be more bloated. You have to write a lot more kind of code in the Docker file to deal with this. You lose in potency, which is kind of a reasonably big deal. This means that if you don't modify the operating system and you just copy the code over, you can realistically take the same image 20 years into the future and or the same Docker file 20 years into the future, and the image resulting container would be the same. If you do update the operating system, that's not true. If you update, if you build the image 1 week later, the resulting, the output will be different. And you can also argue that, why should we care about this stuff? It should be upstream who should be providing us with all these security updates. Why is this delegated to the developer? So in order to kind of argue against that, I've taken a very empirical approach. What you see there is the latest Python image at the point of taking the screenshot, which was might or might not have been like 1 hour ago. And you have this image in the Docker Hub. What I've done is I've pulled that image, and I've written the dumbest Docker file of all time. You can see it right there in the image. It just takes the image and runs apt update. So now what I have is both the Python 3.13 image that was pushed a week ago and an image which is the same but just with operating system patches applied. And what I've done is I've run the Trivy, which is a very well-known vulnerability analyzer, open source. And what you see there is that more than 20 vulnerabilities. Don't be afraid of like the bash piping and stuff. It's just to kind of show the point. More than 20 vulnerabilities have been fixed by this process. And this is just in 1 week. So I think this more or less proves the point. Yes, it's inconvenient. Yes, you take longer to build the image. But in the end, I think security trumps all other concerns, and I would recommend that you include the operating system updates in your Docker files just for this very reason. Also notice that these are critical and high vulnerabilities, so we're not talking about minor things, right? So in the end, I do recommend you do this. And now to finish up, I have a couple more miscellaneous comments, tips, etc. That again, I hope you haven't seen before. If you have, well, sucks to be you. But if you don't, maybe you get something out of this. I really have a pet peeve with this command. It's really dumb. So in many of these images that I mentioned that you will find in articles and such, and if you blindly copy-paste, you will see this Python don't write bytecode environment variable. don't do this. It doesn't work. It's really dumb. And in fact, well, our friend Conrad had a talk yesterday about bytecode, which I find it was extremely interesting. If you didn't get the chance to attend, I highly recommend you watching on tape. And he actually recommended kind of doing the opposite of what this variable does. So he said maybe it would be interesting for you to run the compilation before so that you have your bytecode already compiled by the time the image starts. If you set this environment variable, what it does is essentially postpone or delegate to some degree the generation of bytecode files. And yes, you might have a slightly smaller image size. What it will happen is that these bytecode files will get generated when you hit imports. So you will have big latency spikes in your servers when you hit that code path. It's just very dumb. You shouldn't really scrape to these lengths to reduce image size. Doesn't benefit anyone. Don't do it. Not worth it. If you want to know more, do check out the article in the QR. They explain it in much more length than I can here. Highly recommend that article. And yeah, don't do this. Finally, prefer copy over add. I think this is well known. But just to reiterate, add does more things than just copy. So it will kind of download files, extract files, etc. And you can kind of trap your fingers a little bit with it. It's not necessarily risky, but it's kind of a loaded command, and it's not as transparent as you might think it is. For this reason, I think copy is generally preferred. Copy is just more transparent, does what it says, and you have less risk of side effects by using it. Again, there's another very good article by Docker on this that you can reach via the QR. And these are just more kind of random flags, commands, et cetera, that you might not know about and you might find interesting. And that's it. That's all I have for today. Thank you.
No, okay. Thanks. Thank you, Daniel, for the talk. So we have time for a couple of questions, and there are a lot of questions. So the first one, as developer, I'm waiting for Docker builds on the CI all the time. We're using Kaneko. Do you think it's still a relevant build tool? Which tool do you suggest to build images fast in CI?
Well, I don't know much about that particular tool. I would say it highly depends on your general infrastructure. So in some instances, you might be forced to kind of cooperate with your cloud provider in order to have a faster CI. I have been forced, let's say, to use Azure DevOps in some instances, which also, funny enough, has some problems with caching. So I would say it highly depends. I don't think, well, I'm not an expert on all the different tooling. I just use whatever I'm kind of necessitated to. I will say, in general, the two things you want to be on the lookout for when you're looking for faster build times in CI is hopefully making a smart use of caching. If every build is actually treated as an independent build and you have to pull everything all over again, it's going to be very slow. So watch out and try to rely on some caching mechanism if possible. And the second is to just have a clean Docker file again. So more or less what we've talked about before. Try to not have a very bloated image, and that's where you'll get a lot of gains. And make use of multi-staging whenever possible. If you can parallelize some build steps, that will highly increase your or highly decrease your build time if you can apply it. Other than that, I guess just generic tips. But no, I don't know that particular tool. So, yeah.
Okay, so next question is, should production images contain also the unit test dependencies?
Excellent question. No. So so in general, what you want to do is in order to have a really clean and perfect, and this is again something that takes a bit of time investment, a couple of lines, and that you might not be bothered to do depending on how much you care about these things. But the ideal situation would be that you have either different Docker files or even cleaner different stages to do these things. So you would have a stage that kind of prepares your code, and you would have a different stage that has whatever is necessary strictly for the tests. And in your testing battery, or however you are setting up this testing framework, you would only drag into the final image the specific test things, and those would be completely separate from the production image that you would that would be exempt from those specifics. So no, hopefully or ideally you won't, and you are able to do this via different Docker files or multi-staging. Choose whatever you think is more syntactic, but I would recommend to look into it.
Thanks. So, do you have any opinions about UV's pre-built Python images?
Well, that's so no, I don't have any opinion, but I'm going to go on a slight tangent here because it's maybe partially relevant. So last year I got to speak with Pablo Galindo and Lucas Langa. These are CPython core maintainers and very famous. I'm sure most of you know about them. And I got to ask them a similar question, which was about UV's precompiled Python binaries. So in case you don't know, UV pulls precompiled binaries, whereas, for example, the virtual environment module links to your system's Python installation. UV will actually pull a precompiled binary from wherever and put it in your project. So I asked them about it, and I said, well, what do you think about this? Because they are serving, I mean, we trust them, and I'm pretty sure it's fine, but they are kind of serving a precompiled thing, and Python itself doesn't have it. So what do we do about this? Like, is it just okay? Do you plan to serve some precompiled variants of your own? And the answer was, yeah, we don't bother to do that. It would be kind of too much work, a bit inconvenient, and it would have some maintenance that we don't want to do this, but we fully trust these people to do things properly. We think it's totally safe to use, and we are totally fine with it. So I would say the images, same thing, I'm pretty sure applies, because we're talking about the same group of people doing, in this case, a similar thing. So yeah, I don't have an answer for that, but people who are better than me kind of do for a similar topic, and it should be totally fine.
Okay, thank you. We have time for just one more question. So, Canico is no longer maintained. Google withdrew all maintainers. Is Docker build kit the unprivileged future for builds on K8s?
Again, this is, I guess, this is related to the other question, which I sort of already didn't answer. So yeah, if you have another one, I think for
okay.
Yeah.
So updating the base image still results in the CVs being present. Shouldn't every company offer single snapshot, up-to-date base images? Idempotency is king.
Well, yeah, that's a very tung 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 sahur type argument. Yes, it's true. Updated images also have CVEs, but some of these you have to take into account that they might not have, they might not be fixed upstream. The fix might just not exist yet, and they might be reported, but there's no way of getting a safer image because it just doesn't exist ever nowhere. So yes, I do think that at some point we will evolve to a point where a kind of live patching system or a safer manner of having those images up to date will be built into the system in some way, because this is kind of an important thing, and it's kind of dangerous, and this is happening everywhere. So I think we will get there, and this should happen. Unfortunately, so far it doesn't, so you're kind of forced to do this, so do it, I guess.
Okay, thank you, Daniel.